Hey guys, so in this video, I'm going to dive deep into how to architect large-scale tech projects specifically for enterprise-level scalability. Whether you're tackling a massive user base, handling tons of data, or needing to manage complex feature releases, enterprise projects come with unique challenges. And it's quite different from deploying for smaller scale projects that you want to just ship really fast, like if you're bootstrapping a tech startup or if you're indie hacking, which in my opinion is something I prefer a lot more than managing larger projects. But larger projects are the ones that kind of have the budget to pay the bills, so I think it's worth talking about it. So in this video, I'll walk you through the infrastructure, deployment, and testing strategies that I use to build for scale. Stick around to the end, and I'll also give you a quick comparison to smaller scale setups. And alright, so that's about it. Let's dive into it. When you're building for enterprise, everything is about scale and reliability. That's the number one metric, not development speed, because you're building something that probably millions of users are going to be using. For bigger companies, their priority is not so much about shipping fast anymore, it's about maintaining stability. Here's a breakdown of the main factors that you will face. Number one, high user volume and data load. Enterprise projects deal with thousands, sometimes millions of users, and the infrastructure that is in place needs to support simultaneous access and heavy data transactions without slowing down. Number two, the stakeholder needs are going to be a lot more complex. So you often have multiple stakeholders with different requirements, and this means that feature releases have to be carefully planned, and you might be working with various teams, each with specific functions and deliverables. Number three, having strict compliance and security standards. So unlike startups, enterprises must adhere to rigorous security and compliance regulations. This means everything from data encryption to regular audits, and these things are essential to maintaining trust and legal compliance. Alright, so let's break down a typical enterprise infrastructure. Picture this diagram as I describe it. Number one, user interaction and client load balancing. So at the user level, we've got multiple clients connecting to our application. Here, load balancers are crucial. They distribute incoming traffic across multiple servers, ensuring that no single server gets overwhelmed. For redundancy, I usually have 2 or more load balancers working in tandem. Number two, microservices architecture. For enterprise projects, I swear by microservices. Instead of one massive application, you split it into smaller independent services, each handling specific functions. So for example, a service for user management, another one for payments, another one for email, and so on and so forth, right? This makes it so much easier to scale each component independently based on demand. Next, I want to talk a bit about data storage solutions. Data storage at enterprise level could sometimes benefit from a combination of SQL and NoSQL databases, or you could just stick to SQL or relational databases. It all depends on the scope of the project and your preferences in it. But in this setup, I frequently just use GCP, which is Google Cloud Platform, and Supabase for managing diverse data needs. With GCP, Cloud SQL is my go-to for relational data. It provides fully managed SQL databases like MySQL and Postgres, which are ideal for structured data and very complex queries. Supabase also supports Postgres, and it's excellent for projects that want to go and leverage on open source tools with built-in features like authentication, real-time subscriptions, and then storage. For NoSQL needs on GCP, Cloud Data Store or Big Table can be integrated to handle unstructured data. While Supabase is not a NoSQL solution, it extends Postgres with features that allows for some flexibility similar to NoSQL, such as JSON data types and real-time event handling. So next, we're going to talk a bit about caching data for faster access. With larger scale projects, you need to optimize data retrieval. So what I do is I set up caching with services like Redis. This significantly reduces database load by storing frequently accessed data in memory, speeding up access times, and keeping users happy with really fast load times. For instance, imagine an e-commerce platform with thousands of products like something like Amazon, right? And millions of users. Every time a user searches for a product, the system would typically query the database, which can be quite slow and resource intensive, especially during peak traffic hours. So instead, I cache popular search results for frequently accessed product information into Redis. So when a user searches for a product that's already been cached, they get the results pretty much instantly as Redis delivers the data directly from memory. This approach not only improves the user experience by reducing wait times, but it also alleviates the strain on the primary database. So even during high traffic events like Black Friday sales or whatnot, the system will always maintain responsive and scalable. So next, I want to talk about message queues for asynchronous processing. For high traffic systems, I often use Google Cloud PubSub to manage asynchronous tasks. This is a robust solution for handling background processes like email notifications, data synchronizations, and other tasks that don't need to happen in real time. PubSub lets you decouple services and ensures that every task runs independently without slowing down the main application. So for example, let's say we are running an online learning platform, which is something that I built in the past. when a user enrolls in a course, this triggers several tasks, right? Think about it. It will be something like updating the user's profile, sending a confirmation email, and notifying the instructor, right? PubSub can handle this task asynchronously. So when the enrollment action is recorded in the database, it publishes an event to PubSub. PubSub then pushes this event to various subscribers, one for sending an email, one for updating user profiles, and another one for notifying instructors. Each subscriber processes this task independently, and this way the user gets an immediate confirmation of their enrollment, while the rest of the task runs in the background without impacting performance. Using Google Cloud PubSub as the message queue in this setup provides flexibility and scalability, ensuring that asynchronous processes are handled smoothly even during spikes in user activity. This is going to keep the user experience fast and responsive, which is critical for large-scale applications. By sticking to PubSub, you get a focused and effective solution that fits well within an enterprise-grade architecture without needing to integrate everything into things like Hasura or Supabase specifically for this part of the infrastructure. Moving on to one of the most important parts of enterprise workflows, which is branching strategies and CI/CD pipelines. Enterprise projects need a reliable deployment pipeline to handle complex feature releases. Here's how I set it up. Number one, which is feature branching and git flow. I use a feature branching strategy where each feature or fix is developed on its own branch. These branches eventually merge into development branch, then into staging, and finally into the main production branch. This approach ensures that the code is thoroughly tested and reviewed through each stage before it goes to the production, which is to go live, and this is what everyone else sees when you're ready to go live. Next will be on continuous integration, which is CI. Every time code is pushed to a branch, it triggers a CI pipeline using tools like Jenkins or GitHub Actions. The CI pipeline automatically runs unit tests, integration tests, and linting. This way, we catch issues early on and ensure that only high-quality code reaches the staging environment. Next will be on continuous deployment, which is CD. After passing CI, the code moves to staging, where we conduct more comprehensive testing, including load test and UAT, which is user acceptance testing. And once approved, it's deployed into production. For enterprises, automated CD means deploying with minimal downtime, thanks to strategies like blue-green or canary deployments. These strategies allow us to gradually roll out updates, minimizing risk and impact. Next, we'll be talk about testing for enterprise projects. Testing is non-negotiable, definitely in an enterprise environment. So let's get into the types of testing that I use, right? Load testing and stress testing. For this one, load testing simulates thousands of users assessing the system simultaneously to see how it holds up. And I typically use tools like JMeter or Gatling for this. Stress testing pushes the system beyond its limits to identify potential breaking points, so we know how it's going to behave under extreme conditions. For instance, if you're launching a new e-commerce website during Black Friday, you would use tools like JMeter or Gatling to simulate the expected surge in traffic, ensuring that the website is readily prepared to handle a high number of simultaneous users without crashing. You don't want to find out that it's going to crash only on the day itself, because then it's too late. So you want to stress test it before the day where you expect a lot of traffic coming in. Now, stress testing will bring this a step further by pushing the system beyond its limits to identify its breaking points. So for example, if you expect 10,000 concurrent users but simulate 20,000, you can determine how the system behaves under extreme conditions such as slow response times or complete failure. This insight helps in preparing for unexpected traffic spikes. Number two would be to talk about automated integration tests. Integration tests ensure that all microservices communicate correctly, and I set these up in a test environment with realistic data. The goal is to catch any issues with data flow or service dependencies before they hit production. Integration tests are crucial in an environment with multiple microservices. So for example, imagine a travel booking platform where users can search for flights, hotels, and car rentals, something like that, right? All from different services. You would set up automated integration tests in a controlled environment using realistic booking data. This ensures that when a user completes a booking, the flight services communicates correctly with the hotel and car rental services. Catching issues here prevents disruptions in production, such as missing bookings or incorrect availability information. Number three, we're going to talk a bit now about security and compliance testing. For security, I usually run penetration tests and vulnerability scans regularly. Tools like ZAP, which is Z Attack Proxy, helps to identify potential threats. Compliance testing really is just about making sure that the application meets necessary standards like the GDPR and whatnot, depending on the country and the industry. For instance, if you're developing a healthcare application that handles sensitive patient data, tools like ZAP can be employed to simulate attacks and identify vulnerabilities in your system. This proactive approach ensures that any potential security loopholes are addressed before they can be exploited by malicious actors. Compliance testing ensures that your application adheres to industry regulations such as GDPR for data regulation in EU and HIPAA for healthcare data in the US. So for example, if your application processes personal data, you would conduct compliance testing to verify that data collection, storage, and processing practices align with these regulations, avoiding hefty fines and legal issues, if any. The next one would be regression testing with continuous monitoring. Enterprise projects often require regression testing to ensure that new updates don't break existing features. That's the most painful part of development, right? I remember in one of my early projects, every single time our client or I myself add new features, I have to keep testing the system again, and something else in the past that used to work now start breaking. And I need to test the whole system again and again and again. Every time you add something new, you have to test the entire system again, which is so inefficient. And that's why you need to use regression testing. So after deployment, continuous monitoring tools like Datadog track system performance and user behavior. This way, we're alerted to any issues immediately and can roll back changes if necessary. For example, if you introduce a new payment method in an online banking app, you will run regression tests to verify that current features like fund transfers and account balance inquiries still function correctly, right? So continuous monitoring tools like Datadog comes into play after deployment. So if a user reports slow loading times on a critical feature after an update, continuous monitoring allows you to track system performance and user behavior in real time. If you notice performance metrics drops, you can quickly just roll back the changes to restore functionality, minimizing user disruption. Next will be to talk about enterprise-grade infrastructure and redundancies. With enterprises, downtime can cost millions. So here's how I ensure reliability. First will be to make sure that the redundant server setup is done properly and load balances are done properly, right? In a redundant server setup, multiple servers are configured to take over automatically if one fails, ensuring an uninterrupted service. For example, think of a popular online streaming service like Netflix, right? Well, if one server that streams movies goes down, a load balancer immediately redirects users to another operational server, maintaining the streaming experience without any forms of interruptions. This setup is extremely crucial for high availability systems as it ensures that users can access content seamlessly even during server failures. To achieve this, we use several powerful tools. Nginx functions as both a web server and a load balancers, efficiently distributing incoming traffic across multiple servers. Another option is HA Proxy, an open source load balancer that's known for its impressive performance and flexibility in routing traffic. If you're in the cloud, Google Cloud Load Balancing is a fully managed service that I use, and it automatically distributes incoming traffic into different Google Cloud instances. So for managing the servers themselves, VMware vSphere allows you to run multiple virtual machines on a single physical server, providing high availability and automatic failover. If we're working with containers, Kubernetes is the go-to solution for managing deployment and scaling, ensuring that if one node fails, the containers can quickly be rescheduled elsewhere. Using all these tools, it allows us to create a very strong redundant server setup that enhances reliability and ensures that a smooth user experience is given to our users. Even during unexpected server issues, there will be backups. Okay, now we'll talk a bit about disaster recovery and backup plans. I usually set up automated backups for all critical data and store these backups across multiple regions, just in case something happens. For disaster recovery, we have a well-documented plan that includes regular drills to ensure everyone knows their role. This minimizes the downtime and data loss in the case of a major failure. For instance, imagine a financial services company or a bank that processes transactions daily. If a cyber attack corrupts their primary database, automated backups stored in multiple regions like Google Cloud storage buckets in the US and Europe or Asia can quickly restore critical data. Additionally, conducting regular drills ensures that all employees know their role in the recovery process, much like a fire drill in a school. This preparation minimizes downtime and data loss, ensuring the company can quickly resume operations. Next, it's important to talk about global CDN and edge computing. For faster content delivery, we always use CDN like Cloudflare or Google Cloud CDN. So what it does is it replicates data across global servers, so users access content from the server closest to them. So it loads fastest, right? Edge computing enhances these by processing data at the network's edge, improving speed and reducing latency for users worldwide. For example, consider a very famous marketplace, something like Amazon or Alibaba. During a major sale event, instead of all users accessing the main server, a CDN replicates the website's data across various global servers. If a customer is in Australia and he visits the website, they are served content from a nearby server in Sydney, reducing loading times significantly. Edge computing takes this step further by processing data at the edge of the network. For example, if the same retailer uses edge computing to analyze user behavior on site, like cart additions or item views at local servers, it can provide personalized recommendations almost instantaneously, enhancing user experience and reducing latency. Alright, so let's switch gears briefly. In a startup, you would streamline this process considerably. You might use a single server, minimal redundancy, and fewer testing protocols to really keep costs low and to speed up shipping so you can ship more features in the shortest amount of time. For deployment, Vercel or Heroku are great options because they're so easy to set up and you can manage without extensive infrastructure. The goal when it comes to startup is different. The goal is agility and speed, whereas for enterprises, it's all about reliability and scale. For small-scale infrastructure and startups, we will have a different diagram for it. Typically for startups, we usually have a much smaller user base, right? And this gives us the flexibility to respond quickly to feedback. The client or stakeholders or users are usually fewer, and the requirements can shift rapidly. So I work closely with the users to understand what features or fixes that they need the most. If users express the need for a specific feature or fix in the app, I can implement it within a week or within days instead of months, right? I often use Canny.io to gather direct feedback from users, allowing me to iterate quickly based on their insights. Next up would be to use a way simpler branching strategy. For startups, I keep it simple with a single feature branch going directly to the main branch. You don't need a lot of overhead here, just something lightweight that lets you push updates fast. This way, we can get new features or bug fixes out in hours and not days. If a bug is reported, we can recreate a single feature branch, fix the bug, and merge it into main all in the same day. I typically just use GitHub for version control, which makes it very easy to manage branches and to pull requests efficiently. So keep it simple, remember less is more. And for the startup side of things, I always do deployment with Vercel. I use Vercel for deployment because it's just startup friendly and it's cost effective and it supports quick rollbacks if anything goes wrong. For startups, it's all about reducing complexity, right? Rather than thinking about stability and all that. It's really about keeping things simple because you don't have such a big team. You're just usually 1 or 2 developers. You want to just focus on building new features for your users, right? You want to cut down on infrastructure costs. If a new feature causes an issue, I can roll back to the previous version with just 1 click, ensuring minimal downtime for users. Vercel provides a seamless integration with Next.js, making deployment straightforward and efficient for modern web applications. So next would be to talk about how we do testing and QA, quality assurance, in startup. I do basic automated testing here, focusing on essential functionalities rather than extensive load testing. The goal is to catch critical issues without spending too much time and resources on complex testing, right? Because testing can take so much time sometimes. Quick, frequent releases help us stay responsive to user needs. So for instance, if I implement a new sign-up feature, I will run automated tests to ensure the form submits correctly and the user receives a confirmation email. I use Jest for unit testing in JavaScript applications, allowing for quick verification of essential functions without extensive setup. I also integrate Sentry to monitor applications performance and catch runtime errors in real time, so I can address issues promptly and just basically very quickly improve the overall user experience. It's super fast to set up and it tells you all the details that you're going to need to know whenever there's a bug or a crash, and I definitely recommend this to everyone. So since we're not dealing with high traffic here in startups, we can get away with a more straightforward setup. No need for multiple servers or load balancers, right? The focus here is on agility and speed, with just enough redundancy to handle small scale issues. For a small e-commerce site, I can deploy it on a single cloud instance, scaling only when traffic increases during peak seasons like holidays or Black Friday, right? I often use DigitalOcean for a simple cloud infrastructure, allowing me to spin up virtual machines quickly without overcomplicating things. Okay, so now you might be wondering which approach to take. It really comes down to the scope of your project and your expected growth. If you're working with an enterprise, you should be planning for scalability from day one, especially if you're building for corporates or for clients or for enterprise software. In that case, security and reliability and scalability is a non-negotiable. Whereas for a startup, the priority should be adaptability and cost efficiency. And just know that you can always scale up later as you grow, right? It should be all about shipping new features as fast as you can and focus on the user's needs at the cheapest cost possible. So if you're building for tech startups, please don't go and follow the entire tech stack that I mentioned before this for enterprise, right? I mean, you can, but it will definitely not be efficient, especially if you're just bootstrapping your tech startup and you don't have that much funds. We can always just strengthen the system later on, right? You can make it enterprise grade later on, based on what I mentioned just now, all the tools and all the testing and all the cloud infrastructure. You can do all that later on once you have money, right? Obviously, when you have money and you're more successful, you can spend more time and do these things. Otherwise, just forget it. Just focus on shipping fast, onboarding users, and just building more great features that will give you a competitive advantage, right? That's my opinion. And that's how I approach large-scale tech projects for enterprises. It's all about scalability, remember that, and reliability. You need to plan for high user loads, strict compliance, and complex deployments from day one itself. So if you found this helpful, let me know your biggest takeaway in the comments. And if you're more of a startup person, hit me up for a separate breakdown on how to keep it lean and mean. Yeah, but that's it. Thanks for watching, and I will catch you in the next one. See ya.